All right, let's get into it. Today, we're looking at a pretty incredible paper about a new kind of AI, one that's designed to learn for a lifetime, and it does it all inside the world of Minecraft. And really, it all boils down to this one huge question. How in the world do you teach an AI to master a world that has no instruction manual, no clear ending, and, basically infinite possibilities? The perfect testing ground for this, of course, is Minecraft. But think about it. This isn't just a game. It's a completely open sandbox. For a traditional AI, which usually needs a really clear goal and some kind of reward, this kind of open-ended world is a nightmare. There's no single way to win. So that brings us to what the researchers call the Minecraft Challenge. And the goal here isn't just about finishing one simple task. It's about creating an AI that can actually explore, learn, and build up its own set of skills totally on its own, in a world that literally never ends. And the solution that this paper puts forward, the hero of our story today, is an AI agent they've named Voyager. So what is Voyager? Well, the researchers call it a lifelong learning agent. And the key part of that phrase is that this AI is built to continuously explore, pick up new skills, and make discoveries, all without a human stepping in and telling it what to do next. It just keeps learning for its entire life inside the game. So how does it actually do all this? Well, Voyager's learning process can be broken down into three main parts, or as I like to think of them, it's three superpowers. First up, we have what's called the automatic curriculum. You can basically think of this as the AI's curiosity. It doesn't have a fixed to-do list. Instead, it just looks at what it has, what it knows how to do, and what's around it, and then it comes up with new, achievable tasks for itself. It's kind of like how a human player might think, okay, I've got some wood, maybe I should try to make a crafting table next. Superpower number 2 is the skill library. This is Voyager's memory. Every single time it successfully learns something new, whether that's crafting a pickaxe or fighting off a zombie, it saves the code for that skill in this growing library. And this is so important because these skills can be used again and again and even combined to tackle way more complex challenges down the line. And finally, there's iterative prompting. This is how it practices. Look, Voyager almost never gets things right on the first try. It generates some code, tries to run it in the game, and then it gets feedback, either from the game itself or from a bug in the code. It then uses that feedback to tweak the code and try again, and again, until it works. It's this simple but really powerful loop. Try, fail, learn, and repeat. And these three superpowers are always working together in this perfect little cycle. The curriculum, its curiosity, asks, okay, what's next? The iterative prompting figures out, how do I actually do that? And once it succeeds, the skill library remembers that solution forever, making the whole agent just a little bit smarter. Let's look at a real example of this learning loop in action. So here, the AI tries to craft an acacia_axe. Now, if you've ever played Minecraft, you know that's not a real item. So, of course, the game's code interpreter spits out an error, basically telling Voyager, hey, I have no idea what that is. And here's where the magic happens. Using that very specific error message, Voyager corrects itself. It changes the code to craft a wooden axe, which is a real item, and boom, it works. It just learned from a mistake, and the correct code for making that axe is now stored away in its skill library. Okay, so the theory sounds really cool, but does it actually perform better than other methods out there? Well, let's put Voyager to the test and take a look at the results. This chart right here is the headline result. It shows a head-to-head race, comparing Voyager to other top AI agents like AutoGPT. The line going up shows how many unique items each AI discovered over time. And as you can plainly see, Voyager's learning curve, that bright orange line, just skyrockets past everyone else. It's not even close. So let's break that down with some numbers. The results are pretty staggering. Over the course of the experiment, Voyager discovered 3.3 times more unique items than any of its rivals. And it's also way, way faster at learning the basics. When you look at key milestones, like just crafting the very first wooden tools, it's an incredible 15.3 times faster. And on top of that, it's just a better explorer. It travels 2.3 times farther, covering way more ground and seeing more new things, while a lot of the other agents just kind of get stuck walking in circles. This table really drives the point home. It breaks down how far each agent got up the game's tech tree, from wood to stone to iron and finally to diamond. And the difference is just stark. Other methods like React and Reflection completely failed. They couldn't even get started. AutoGPT gets to iron, but then it just stalls out. Voyager is the only one that successfully climbs the entire tree, all the way to crafting diamond tools. That is a huge deal. So what does all of this actually mean for the future of AI? Well, that brings us to Voyager's true legacy, that incredibly powerful and reusable library of skills. Because, the real test of learning isn't just about mastering one single world. It's about being able to take what you've learned and apply it in a totally new situation you've never seen before. It's something called zero-shot generalization. So the big question is, can Voyager actually do it? And the answer is a resounding yes. Here, we see Voyager get dropped into a brand new world with a new task. The orange line on the left shows that with its pre-learned skill library, it solves the problem no sweat. But when you take that library away, that's the purple line on the right, it struggles just like any other AI. This is the proof that reusable knowledge is its real superpower. The researchers themselves summed it up perfectly. They said Voyager serves as a starting point to develop powerful, generalist agents without tuning the model parameters. And that's the key takeaway. This isn't about just building a bigger and bigger model. It's about creating a fundamentally smarter learning process. And that is why this all matters so much. This goes way beyond just a video game. This whole idea of an AI building up an adaptable library of skills it can reuse, well, that's a potential blueprint for the future of general-purpose AI, from robots in manufacturing plants to complex automation in science labs. Which really just leaves us with one final kind of mind-bending thought to chew on. If an AI can teach itself to master a digital universe made of blocks, what real-world universe will it master next?